In this video, I want to talk about the idea of the number of dimensions of a space, and also the idea of extra dimensions as it applies to our universe. What would it mean for our universe to have extra dimensions, as some theories like string theory sometimes suggest? So the basic idea of the number of dimensions of a space, one way to describe it is it's like the number of independent directions you could move in starting from a point in that space. So let's do some examples. I'll start with the simplest example of a zero-dimensional space. So 0 dimensions would mean that there are 0 directions you could move in if you were on a point in that space. And so that would be like just an isolated point. So that would be a 0-dimensional space, or a collection of isolated points that are not connected together in any way. So I could be at any one of those points, and at any of those points there are no nearby points. There's no direction I could move in. And so that would be, those are various examples of 0-dimensional spaces. The next one would be a 1-dimensional space. And so that would be a space like this glitch that just happened on my computer screen. A 1-dimensional space just appeared there. So if I look at a point on this 1-dimensional space, like that point, you see it has some nearby points to it. And so I could pick a direction, and there's actually just sort of one direction that I could move forward in, and then I could go backward in the same direction, and that would kind of allow me to get to all the points that are close to that point. Okay, so that's a 1-dimensional space because there's really only one independent way I could move, and I'm counting forward motion and backward motion as being the same direction. What about a 2-dimensional space? So a 2-dimensional space, that would be one where I have maybe the surface of a piece of paper, or the surface of a sphere, or some more general kind of curvy space like this. And so you see, with a 2-dimensional space, then I could choose a direction to move in. I could go forward or backward in that direction, but that wouldn't cover all of the possibilities for the points nearby the point that I started with. So I could choose a different direction that would be independent of those ones. So say going in this direction. It's common, if we have some way of measuring angles, it's common to choose this new direction to be perpendicular to the old one, but we don't have to. So if this one is our second direction, we see that you can't really get to these points along this line by just going backward and forward along the original line. Okay, so that's now 2 independent directions that we can move in. Now you might say, well, there's lots of other directions here, so what about this direction? That looks like a 3rd direction that we could go in. But you see, that one's not independent of the other 2, because if I'm allowed to move along in this direction and in the other direction, then a little motion in this direction would be sort of equivalent to a combination of motions in my 1st direction here and in my 2nd direction there. And so we would say that 3rd direction is not really an independent direction. So there's really just 2 independent directions. If I'm allowed to go in these 2 directions, I could get to any of the points nearby my original point. And same thing on a sphere. I could travel along, say, lines of latitude on the Earth, and I could travel along lines of longitude on the Earth. And by moving in these 2 independent directions, I could get to any point on the Earth. So of course, our actual universe is 3-dimensional as far as we can tell. So a space with 3 dimensions has one more extra independent direction. So we are used to living on the Earth, where we could go in the north-south direction, or we could go in the east-west direction, and we could combine those to go in any direction we want. But of course, you could also imagine going in the vertical direction. So that's a third independent direction that you could never access if you were just going north, south, or east, west on the surface of the Earth. A different way to describe what it would mean for a space to have a certain number of dimensions is that it is like the number of numbers you would need to give coordinates for the points in that space. So on my one-dimensional space here, I could imagine marking off a one-dimensional grid and labeling all these points by integers 0, 1, 2, 3, 4, minus 1, minus 2, and using the real numbers we would be able to then describe all of the points in between those integer grid points. And so in the vicinity of this point here, 0, I could use just one real number to describe all of the different points in this space. Similarly, for my two-dimensional space, I could describe all of the points in the vicinity of my original point by using a two-dimensional grid. So by using a pair of numbers, I could say start with this point, call it 0, 0, draw the two-dimensional grid, and I could then take any point like this one here, and I could label that point by a pair of numbers. 2 for going 2 steps this way, and then 1 for going 1 step that way. And so you could see that any point here, even the ones in between, that one might be 1.7 and 1.7. And so there would be this efficient and unique way of describing all of the nearby points here by using a pair of real numbers. Okay, so 2 numbers, 2 dimensions. Similarly, for 3 dimensions, I would use 3 different numbers. If we were talking about points near the surface of the Earth, I might use latitude, longitude, and altitude, how far above the surface we are, and then I would be able to describe all of those points. So let's get a new canvas here and think about what it would mean to have a space with more than 3 dimensions. So what would it mean to be talking about a 4-dimensional space? So this is difficult for us because it's hard to draw. A 4-dimensional space doesn't really fit on a piece of paper or even fit into our 3-dimensional universe. And so it is actually very hard for us to visualize a 4-dimensional space. But we can certainly imagine this mathematically, so we could sort of abstractly construct the idea of a 4-dimensional space. We could just imagine that going from 0 to 1 to 2 to 3, we keep adding this new direction that we could move in. And so we could just sort of imagine abstractly perhaps that there would be another direction, that there's some kind of space that would have one more direction. And so you can kind of notice that like this line, we could say it's a collection of an infinite number of points along the new direction. And this square here is like a collection of an infinite number of these lines spread out along our new direction. And this cube is like an infinite number of these squares spread out along the new direction. And so we could visualize, say, a 4-dimensional space as being some infinite number of these 3-dimensional spaces spread out along some new direction. And then to describe points in this 4-dimensional space, we would need a 4th coordinate. So say we would label where we are along the new direction by a 4th coordinate. And then this point would be 3, 4, 2, and maybe 7 if we're at 7 units of distance along this new direction. Okay, so why would that be relevant to our own universe? Why do some people say we might have extra dimensions? Clearly, our experience is that there isn't this extra dimension that we could move into our experience is that there are only 3 possible ways you could go from any point in our universe. So what would it mean if our universe actually has 4 dimensions? Well, there are a couple of ways to visualize this. A couple of ways to understand how it could be that even though we experience only 3 dimensions, there could possibly actually be extra dimensions. And so I am going to give you a couple of scenarios where we'll be able to understand this. And so it's much easier to imagine a creature that thinks it lives in 1 dimension, and I'll give you a scenario where that creature actually secretly is in a 2-dimensional universe. And so the universe that this creature lives in is actually in the shape of a garden hose. Okay, and so you see this is a 2-dimensional space because there's one direction along the garden hose, and then there's another direction around the garden hose. And so like the piece of paper or the sphere, there are 2 independent directions you could move in. So 2-dimensional space. But now suppose that the creatures in this 2-dimensional universe, their atoms are actually objects that go all the way around this garden hose. So maybe the creatures here are made of these rubber band atoms that kind of stretch around the garden hose. So here's a person in this universe. Okay, and so let's think about what is the experience of this person. And so maybe these people are made of many different atoms, and so they're all stretched around, and maybe they're not even aware that they're made of these atoms. All that they can experience in their world is the fact that they could move in this one direction along the hose. They could slide over here in this way, or they could slide over there in that way. And so according to their experience, there are just, there's just this one direction they could move in, forward or backward. And so this person experiences 1D, but actually their universe is 2D. Okay, so that is like one possibility for how our universe could potentially have extra dimensions. So maybe we experience 3 dimensions because the other dimensions are, perhaps they're small in a sense, like rolled up like this direction of the hose, and maybe all of the particles or atoms that we're made of are actually spread completely over this 4th dimension. Okay, so we would just not be aware of it. There could even be 5 dimensions or 6 dimensions if some of them are just these smaller dimensions where we were completely spread over them. Okay, and so that's one idea. Some models of string theory suggest that there are actually 9 total space dimensions, and so that would mean there'd be like 6 of these small ones where the particles we're made of are spread completely over those, and then just 3 big ones that those particles can move in. Let me tell you one more scenario for how there could be extra dimensions, and in this other scenario, the extra dimensions might even be larger. So I think I'll get myself a fresh canvas here. Choose the pen. Okay, so here's the second scenario. And in this scenario, I'm going to tell you about some creatures that think that they live in 2 dimensions, but actually they really live in a 3-dimensional universe. Okay, so here is the scenario. So imagine that there's actually, something like part of the ocean. So a body of water. And then you have these creatures that float on the surface of the water. Okay, and they can't see anything. The way that they communicate is just by ripples on the surface of the water. So they can talk to each other, and they could kind of detect other things in their universe by the fact that they can transmit ripples on the surface of the water to each other. And so for these creatures, well, they could just move around on the surface of the water. And they could see things in their universe nearby on the surface of the water. Oh, my computer's going crazy here. Let's fix that. Okay. Okay, that should be better. But secretly, there's this third direction that maybe they can't move in because they're just floaty creatures. They have no way of moving in that direction, and they can't kind of perceive anything because they don't see light or anything. All they can use to communicate are these ripples on the surface, and those just by definition can only exist on the surface. Okay, so we could imagine a model of physics like that. Sometimes these are called brane world models. So brane here is short for membrane, and so we could imagine that, you know, like all of our stars and galaxies and everything are actually living on the surface of some higher dimensional space. So maybe there's this fourth space dimension out in this way, and then maybe all of the photons and light waves that we use to see things or communicate, maybe those are actually just physically things that can only live on the surface. But then secretly there are these other dimensions. Okay. So those are kind of the two most common scenarios for how there might be actually extra dimensions that we are not aware of. Either our particles are spread over small extra dimensions like the circular direction of the garden hose, or all of our particles that we're made of and all the light that we see things with is just physically stuck to a three-dimensional space, which is actually secretly the boundary of a higher dimensional space, and we're not able to probe that space directly. Okay, so that is all. Hopefully that gave you some idea of what it means for a space to have a certain number of dimensions, and also how it could be possible that our own universe might have more than 3 dimensions.